And welcome everyone to AAA Houston section, SpaceGeekSpeak, Saturday informal events. We are thrilled to have our guest today, Deb Ludban. And I will just read a short introduction, and hopefully you will enjoy it as much as I enjoyed creating this introduction. Since joining NASA in 2000, Deborah Ludban has embarked on a journey that most of us only dream of while staring at the night sky or watching a sci-fi movie. Starting as a quality engineer at the White Sands Test Facility, Deb quickly became an integral part of the team, proving that rocket science might just be as complex as assembling IKEA furniture, but with fewer leftover screws. Her journey took her from testing space shuttle hardware to shaping the future of space exploration at the Johnson Space Center, where she navigated through various exploration programs with the grace of a seasoned astronaut dodging space debris. As the current manager for vehicle system integration in the Gateway Program Office, Deb ensures that our celestial chariot is up to the task across all Gateway systems, essentially making her the master conductor of an interstellar orchestra. With a bachelor's degree in engineering from New Mexico State University and a master's certificate in space systems engineering from Stevens Institute of Technology, she is well equipped for the job. Whether it's herding celestial bodies or fine-tuning the universe's most ambitious vehicle, Deb's excitement for the future Artemis missions is contagious, and leading a team of rocket scientists and engineers is no small feat. It's kind of like organizing a spacewalk, but everyone's floating in different directions. Yet she navigates this with unparalleled expertise and sense of humor that reminds us all why exploring the unknown is not just important, but undeniably thrilling. Welcome, Deb, and we are happy to have you here and can't wait to hear from you.
It is so nice to hear from you too, Svetlana. I think Svetlana should be a creative writer in her other life, because she certainly put some magic into words and had me giggling and smiling the entire time as we were going back and forth and she was writing her introduction. So thank you very much for that, Svetlana. I am excited to be here. I hope I can live up to the hype a little bit. I do have a set of slides. I'm going to try to go through them relatively quickly because I was lucky enough to be able to join last week and I got to hear the great discussion afterwards. So Svetlana did a great presentation on Women's History Month, and I want to continue to bring some of those flavors in, as well as to talk about the Gateway program, which is where I and get you all up to speed if you haven't heard very much about it to date. I am happy to take questions. I don't think that I have anything that's super secret, and this is relatively high level, but I love digging in, and hopefully you can see my excitement about it as I continue to work in this area with some really amazing people, including Svetlana. So I am going to share my screen here. See if it works. Oops. All right, can you all see that?
Yes, if you can turn into a presentation mode. Now, yes.
I will do that. Thank you. I almost never get to use Zoom anymore, so I am out of practice, and it still does not want to. Oh.
So now in that display settings, you switch, flip it, or that.
There we go. Did that work?
If you can hide the, something happened.
Okay. As you can see, I am an engineer, not a presenter.
Perfect. This is good.
All right. Are we back?
Yes.
Okay. Awesome. Well, I will jump in. I'm very excited. As Svetlana mentioned, I am the manager for the Vehicle Systems Integration Office in the Gateway program. And oops. To start off with, I'll show you a few pictures of what we're hoping it's going to look like. Now we have a pretty good idea of what it's going to look like as we've got the primary structures adapted, but there are still some things that we're working on. So give us some grace as we continue to use these amazing models to further develop the picture that we're building. So the Gateway program is the program that is in charge of building our first and only space station that goes around the moon. We are doing this under the umbrella of the Artemis program, or the Moon to Mars program with the Artemis missions. This is a baby brother, baby sister to the International Space Station. We are certainly learning a lot from them. Our space station is made to last about 15 years in lunar orbit, but just like the International Space Station, we're hoping that it lasts much longer than that. And this is going to enable access to the lunar surface from all sorts of different ways. And I'll get through a little bit more of that over the next few slides. I know I usually hate org charts and these kinds of things, but I did want to mention a couple of things, specifically as Svetlana was talking about Women's History Month. So you can see the organization overall. We've got a pretty typical NASA organization with level 2 integration office. So we've got our program planning and control and systems engineering and integration, which is really a sister to my team, which is the vehicle systems integration. We've got the safety and mission assurance and mission integration and flight operations as our sort of level 2 integration team. The interesting thing about this is there is no prime integrator, so that we do not have an integration contractor. All the level 2 integration across all of these specific projects is happening by NASA right now, which is really exciting for us. We're building our chops back up in how we do large scale integration this way. And then along the lower part of the chart, you can see the level 3 project offices. So those are our different modules that we have that are coming together, similarly to the International Space Station, how different pieces are going to come together over time. It's going to be built up over several years. And I'll go through each of those different areas along with our international partners. And then along the very bottom, you can see some of the prime contractors for each of these modules. Like I said, there's no level 2 integration contractor, but each of these contractors across the bottom, as well as a few others, are building significant pieces of equipment that are coming together. And so that's our challenge and our joy is stitching all of these amazingly different types of contractors and hardware together. Now, since Svetlana did talk a little bit last week, this is my very crude way of showing the influence of women in this program organization. As you can see, I put very stereotypically, I put pink dots next to the women and blue dots next to the men. And you can see it is nearly a 50-50 break in our male-female ratio, which is huge for technical programs. NASA is certainly getting better and I think leading the way. But if you showed this at a Department of Defense organization or DARPA or some other team, you would probably see a whole lot less pink. I'm very excited to be part of this team. Dan Hartman, who many of you have probably heard of or know from the past from the International Space Station, was the initial program manager. He retired last year. But he really focused as he was building up this team and building up these leaders that he wanted to make sure it was a very diverse workforce. So I show the male-female ratio here. However, we also have about a third of our lead organizations have minorities as the leaders as well. So for example, my deputy is from South Asian descent. And so she has a different cultural background. We've got African Americans, we've got Hispanic Americans, we have some Middle Easterns of heritage that are all scattered throughout these teams. And we're very excited to bring not just diversity with men and women, but also cultural diversity and backgrounds. For example, I grew up in a very small town. Several of these folks grew up in the city, or even there were a couple that lived in even smaller towns than I did. And so it's important to get that diversity of thought. That's really important. And that was one of the keys that Dan developed as he was really bringing our team together, is making sure that we've got diversity of thought as well as diversity of backgrounds. In addition to that, several of these teams are actually led out of different centers. So the program and propulsion element, for example, is managed out of the Glenn Research Center. Habitation system development is managed out of Marshall, and deep space logistics is managed out of Kennedy Space Center. So in addition to all the other areas of diversity, we've got also diversity of centers, which has a very different cultural diversity, as I'm sure many of you know. So it's a very exciting organization to be part of. All of this flows under the umbrella of Artemis, though. We're very, very excited to be part of this series of missions. As hopefully many of you know, Artemis 1 was complete a little over a year ago. It was a beautiful, picture-perfect launch, and it's a great foundation for how we're going to get our crews up to the Gateway and to the lunar surface. For Artemis 2, the crew is selected. A great picture there. Once again, a wonderfully diverse crew, including the first Artemis Canadian astronaut. And he is actually on this mission, on Artemis 2, specifically because of the Canadian participation in Gateway. And I'll talk a little bit more about the international participation coming up soon, too. Artemis 3 is going to be the first crewed landing, and so that is where two major crew modules are coming together. So the Orion vehicle and the Human Landing System vehicle are going to come together and dock together directly in the lunar orbit, and then bring crew down to the lunar surface. And Artemis 4 is our first Gateway mission, where Orion will bring crew up to the Gateway lunar space station, and we'll do crew transfer and checkouts there prior to going down to the lunar surface. The Gateway, as I mentioned, is going to be built up over many, many flights, and that means over many years, as the current flight cadence for Artemis missions is about one a year. The first few, of course, are going to be a little bit longer as we're continuing to learn and develop. So our first two foundational elements are going to go up as part of, actually prior to Artemis 4, so that they are in place for Artemis 4, and that's the power and propulsion element and the habitation and logistics outpost. We call it HALO, and they will be launched on a SpaceX Falcon Heavy, and they will be pre-staged out in lunar orbit. They're going to take a very slow spiral. I'll talk a little bit more about the propulsion system on the power and propulsion element, but it is a solar electric propulsion, which is I'll take a quick break, just a second. So since I am working from home today, you might very well see kids and cats popping into my picture. So I'll apologize in advance for that. I have a cat, of course, coming to join me now. So as I was saying, the slow spiral of the power and propulsion element going out to lunar orbit is really important for us because it is an incredibly economical way of doing propulsion. So I'll talk a little bit more about solar electric propulsion in a little bit. But after we get our first two elements out to lunar orbit, then on Artemis 4, we will have Orion bring our next element out. So rather than having a special propulsion stage on each of our individual elements as they come up, we are having Orion bring the next few, which is really exciting for us. So on Artemis 4, Orion will be bringing our international habitat module. And so that will really expand the amount of space that the crew has to live and work in space. And that will be launched on the the SLS Block 1B rocket. And that will be the first co-manifested payload, is how we refer to these elements that Orion is bringing up. On Artemis 5, Orion is going to bring up our Esprit refueling module, which is another of our ESA developed modules. And at the same time, or around the same time, we will also have a logistics module that is delivered up to the Gateway, and it will bring our Canada Arm 3. So in addition to Canada supplying the arms for the shuttle and ISS missions and vehicles, we're going to have a very similar one, which is the next level in robotics technology on Gateway. On Artemis 6, Orion will bring our airlock module. That will be our final main module coming up, and that will also be launched as a co-manifested payload on Block 1B. And then finally, as part of Artemis 7 and beyond, the Gateway will be fully outfitted with its modules and will be finalizing interior fitting, making sure that it is able to maintain as a habitat for long-term locations in space. As I mentioned, a couple of our international partners on the previous page, we are super excited that we are expanding our international partnerships as part of the Gateway mission. So we always have our very traditional standbys of partners. So Canadian Space Agency, as I mentioned, is bringing up a new robotic arm. European Space Agency is the lead integrator for the international habitat. And also they are the prime for the refueling modules, as well as a lunar communications asset that's actually being installed on HALO. The Japanese aerospace company JAXA is going to be developing major portions of the IHAB, including the environmental and life control systems, as well as pieces across all of the different modules like batteries and some of the thermal control and imagery components. And our latest and greatest partnership, this is incredibly significant for us. It's the first time a partner has been involved in NASA to this level of degree in over 25 years. The United Arab Emirates is bringing forward our airlock, and out of the Mohammed bin Rashid Space Center. So we call it MBRSC because it's a very long title, just like NASA is. They are bringing our airlock module, which will include both a crew and a science airlock. Now, MBRSC is relatively new to the space game. They have been, they were started, I think, in 2006. And so they have done great things by learning and building off of other grounded space organizations. They have launched a couple of different satellites, which include many of the systems that we'll be using on the Gateway as well, with their power and their thermal and comm systems. But the human aspect is going to be the new piece for them. So we're very tightly integrated with them as how we're going to do life support, how we're going to do crew engagement and crew interaction, do crew to human equipment like audio equipment, and then of course things like having to be aware of acoustics and the reach of humans, and humans being able to operate a vehicle is all new for them. So they're very excited about it. We actually had a team here about a week ago from MBRSC, and they are going to come along wonderfully, and we're going to support them very well. I did want to mention here, and as I go through this, I'm going to talk some of the interesting challenges that we've been coming across as part of the Gateway development. Specifically, with our international partners, we're treating our partners a little bit differently here. So in the International Space Station, it was really a NASA-developed system, and then we kind of sliced off portions and gave those portions to the different international partners to go off and develop. However, it was really a centrally run program where the expectation was very clear on here's your responsibility. We maintained central leadership for things like safety reviews and hazard reviews, and making sure that we had hazard controls understood across all the vehicles. And even in Orion, the European Space Agency developed the service module for Orion, but it as a subcontractor to their prime. So it really was a very transactional relationship. And it was, here are your requirements, ESA. Now build me exactly this and bring it in, and we will integrate it as part of a NASA design of integration. For the Gateway, we're treating them very differently. For the Gateway, not only are they in charge of building their module, but they are in charge of the prime contracting of their module and doing down and in requirements development. The partners will also be in charge of making sure that all the training is understood and having their own training systems, as well as their own mission control systems for each of these modules that they're bringing up as well. Each of our partners is responsible for long-term sustaining engineering of each of their components, no matter where they are across the vehicle. Like, for example, ESA has pieces in a few different vehicles, as does JAXA, and as does NASA. So each of the partners is really wholly responsible. We have now delegated things, delegated things like safety reviews to each other than MBRSC, as they're relatively new in this human space game. But the other three partners are established enough that we balance that trust with providing them a little bit more autonomy in their development. And they are much more a truly partner sitting at the table with us. And we show that in every way. So at all of our control boards, they are part of that control, not just our level 3 module development, but as a level 2 partner. So we're really stretching the capabilities of what this partnership entails. And you see that through the things that they are given. For example, we've got the Canadian Space Agency astronaut that's on Artemis 2. We've got actually 2 flown UAE astronauts now that are part of the International Space Station crew, and that is part of their development in NASA and building over long term. So 2 more astronaut candidates from the UAE were actually inducted in the astronaut candidate class of, was it a week and a half ago or so. We're excited to continue to build those capabilities and to build those relationships. So this is our expanded view of the Gateway. Each of these, I've kind of talked through some of the pieces. Forgive us, we've got a NASA reference mission of the human landing system instead of, as we all know, we've got SpaceX and Blue Origin on contract for those, but we're not allowed to use them publicly yet. So, so you see an expanded view of the human landing system. However, most of this, you see how all of the different pieces of Gateway are going to be coming together over time. So one of the incredibly important things that we did prior to really getting Gateway started, and it was launched out of our International Space Station activity, is coming up with international standards for how we do space development. And that's been incredibly important in how we pull together built over time station like this. So the first, and in my opinion, probably the most important, but all of them are important, is the international standard for docking. And what we did is we took our traditional partnerships from the ISS, and we came together and we said, okay, if we're going to have one deep system, what is it going to look like so that things can actually connect? So we have an international deep space standard for docking. We also have international deep space standards for power and avionics and communication and a few other things as well. Thermal is one. So using these standards that the primary agencies have already come up with and identified and decided are the most important has been foundational to build up a space station that works over time. So all of these things can actually be developed by independent teams and still come together and work. Now, those international standards by themselves don't give you all of the information in order to be able to, say, dock with Gateway in the future. However, you will physically be able to connect, and you will actually be able to communicate if you follow these basic standards. Then if you want to do anything more than that, then there's probably a little bit more that we'll have to introduce with you. But that is the foundation of making sure all of these things can come together over time. So it's a really huge deal for us. Let's see, Gateway orbit. And many people have asked about why it's necessary to do this kind of an orbit. Hopefully the video is coming through over on the right, but you can see how we have a halo orbit, which basically means it's an egg shape. It's a long and skinny oval going around the moon. We did this for many, many different reasons. One was because the scientists want us to go back to the pole. They don't want us to go around the equatorial region, which is where Apollo went. The equatorial region is great, and it was a foundational way in showing space travel and how we can actually land on it, and we will continue to learn and grow from that. The scientists are now most interested in the poles because that's where the water is. So we wanted to make sure that we had pole orbit. Another thing that we wanted to make sure is that we had access to all areas. So as you could see in that video, the orbit that we're on will track around the moon over time. So you will have access to all sorts of different areas. It's also a very stable orbit. So when we're talking about a 15-year lifetime for a vehicle, we want to make sure that it is able to stay refueling, because it is incredibly costly to us and anything out to the vicinity. So we wanted to make sure that it was going to be a very stable orbit, and thanks to orbital dynamics and mission design, this is a great stable orbit. It also is favorable for science because it has a great vantage point for the Earth, for the sun, as well as deep space. It will track around to the dark side of the moon, which is really an incredibly quiet, dark place that we don't have very much data about. So we'll be able to collect data on that side, as well as, since it does have that relatively long orbit, it's about a 6.5-day orbit, it will provide nearly continuous view of Earth, which allows for lunar or Earth to moon communication really well as providing communication for its own self, the Gateway, around the lunar orbit. It will also act as a communication relay for other things that are on the lunar surface, that since they are on the surface and they're steady, they're not going to be able to always get that same communication line of sight. And so we wanted to make sure that the Gateway was available as a relay for those kind of stuff. All right. So now moving on to science a little bit more, and this is another primary reason why we picked the orbit that we did, but also why we picked the Gateway. While we are around the moon, we don't want to just stay for the or even just a few days. We want to be able to provide scientists the ability to do long duration outside of the Earth's magnetosphere and atmosphere science and data collection. So the location that we are at will give us huge opportunities for all of the different types of science that you see down on the screen there. And so I'll talk a little bit coming up. So this is a little bit of a picture of how you can see the Earth and Sun reacting. So, you know, we're very lucky. I can't say that we're very lucky. I think the way the solar system was designed was for Earth to have this incredible power of both absorbing the energy from the sun and pushing back against some of the energy from the sun. We know that one of the highest causes of base failures is radiation effects. And once we get a little farther away from the Earth, radiation becomes a huge deal for us. But it's not just radiation, it's all of the different dynamics that come into play once you leave some of the protection of the Earth's atmosphere. The ISS still is able to enjoy a lot of those protections, but once we get out into the lunar surface, a lot more of those go away. So as we're thinking forward to Mars, for example, as we're thinking forward to longer duration human spaceflight, we need to figure out how our systems and our people are going to live and work. So it's incredibly important for us to be able to look at the interactions between the bodies of the solar system and figure out what is going to work, what is not going to work. So we've got lots of different ways that we're going to be testing things like radiation. We've got lots of different scientific instruments to be able to study the environments around us. We've also built in systems into the gateway such that we can repair and replace over time, because we are not sure what this kind of environment is actually going to do to the gateway. In order to go to Mars, we need to be able to test out some of those systems while we're still relatively close to the Earth's surface, but we're still far enough away to get rid of a lot of those crutches that we lean on. We're talking about how we're going to live and work long term. So even in your mind, it's a huge difference being a few hours away from Earth like you are on the space station, to a few days away from Earth like you'll be around lunar orbit, to months away from Earth like you're going to be on Mars. And we have to figure out how we're all going to work together between humans and our systems supporting us. So a few of the initial, and even before we have people on the gateway, these instruments are going to be available and collecting data and helping us better understand. They're all jointly developed as part of our partnership. So that's another interesting thing about the way we're doing science on Gateway. Since we are a true partnership and we have equal members sitting at the table, when we get this data together, we will share it amongst all the members. And each of the specific science payloads that are going up on the Gateway are also collaboratively identified and narrowed down such that we're not duplicating equipment across different providers, and where one partner, for example, really wants to focus on a specific technology, the other partners can support that and maybe build a better machine or a better instrument such that they can get all the data they want, and then everybody shares all that data. So the first three that are already well into development are the European radiation sensor arrays. So that will really help us understand how we're monitoring the radiation at the higher energies and focusing on the space weather. We've got the internal dosimeter array. We use the acronyms, of course. So URSA and IDA are the ones that we're used to. IDA is being led by JAXA, but that's really going to look at radiation physics and how that affects people. And so how the crew and a little bit of the hardware, but really how the crew is going to react to the radiation environment. And then Hermes, which is the Heliophysics Environmental Radiation Measurement Experiment Suite. And that is basically a space weather instrument. So that's going to be looking specifically at the sun and the solar winds and how all of these things interact once again in lunar orbit. So continuing to build our knowledge about the solar system and how we will be able to long-term live and work in space. So now we're back to the and we're going to launch our first two modules, the power and propulsion element and the halo, up in just a few years. We're very excited about this. The power and propulsion element main pieces are, it is providing overall solar electric propulsion for our spacecraft. That provides our transit for this integrated stack out to lunar orbit. It is the main communications relay with Earth, and it will maintain Gateway's orbit. Halo, on the other hand, is a very, very small, but it is a habitable environment for up to 4 crew for up to 9 days. Once again, we don't have a way to get people to the Gateway except with Orion or another future space vehicle, and by itself it will be quite tight. But once we get it fully outfitted out, the crew will have a little bit more range. On Halo is our lunar command and control, or lunar surface communication system, and provided by NASA. And then of course Halo is where we'll have our docking ports for the future modules that come up, as well as logistics and any other visiting spacecraft that are coming. So our power and propulsion element is developed by Maxar, and here let me get into a video. So as you can see, the start of the buildup that we're already doing, our primary structure, of course, is already developed. The xenon tanks, the fuel tanks have been inserted. We're making avionics, and in our power system and our power distribution system and our communication. I want to mention that this is a huge partnership with our commercial development team. Maxar, if you haven't heard, is a supplier of satellites and has been for many, many years. They've got hundreds of satellites flying in Earth orbit. foundations that we were trying to do when we developed Gateway is figuring out how we can take the amazing things that, let me go back, take the amazing things that the commercial industry provides and just give them a boost. So how can we take this industry that is already thriving, take them to the next level by infusing technology, infusing expertise, partnering with NASA so that we can do even bigger and better things together. So one of the things that you'll see that you see on the screen right now is one of the solar electric propulsion engines. Maxar has been using these solar electric propulsion engines for a very long time, but at a relatively small scale. They are very efficient. They use xenon as their fuel. A very low ISP, but you can build that up over time so that they've got the proper thrust to maintain orbits. What we did is we partnered with Rocketjet, Rocketdyne, excuse me, and built an even larger thruster for solar electric propulsion. And those are the thrusters that are being installed. So we're enabling these two companies to live and work together, building up a comprehensive spacecraft, utilizing the technologies that they do best, and building up that same kind of commercial experience that they can use this technology and use this for the future and building up their system. So while the Maxar-based power element is based on their current comm satellites, it is oversized in every way. So it needs to be overall bigger than what they normally do. The amount of solar electric power that they are collecting is more than they've ever done. They're using new technologies. However, they're also using many of their same commercial practices and processes that have made them very successful over time. So it's a good job to make sure that we're building up our economic development as well. The next piece is the habitation logistics outpost, and you can see a beautiful picture of our primary structure there. I don't know how they did that lighting, but it just glows like a diamond. I'm very excited when I see that. And we'll see a little video here of them putting together that same primary structure. So the primary structure for Halo is actually going to be the main foundation of our primary structure that we're also using for IHAB and possibly also using for our airlock, and definitely also using for our refueling module. Same kind of core built on over time. This is based on the Cygnus modules that are Grumman, and they're built actually in Thales. And so we've got great history on this as well. Axiom is also using the same company to build up their primary structure for their modules as they're doing in low Earth orbit. So some of the interesting things that we've been going through as we've been developing our commercial entities and really trying to partner a little bit more with our commercial providers is that some of them aren't super pleased with us. So what we did in Gateway is we tried to give each of our providers a lot of flexibility in determining what kind of structure that they wanted to do and determining what kind of power system or avionics system they really wanted to incorporate. And so we didn't specify that you had to use this contractor or you had to use this structure. What we specified is some very functional requirements and then allowed them to go off and build for themselves. It just so that as the different people were coming together and coming up with what is the right thing to do, many of them came to the same conclusions. For example, in primary structure, many of them are going back to Thales and using the same very space-proven primary structure. They're also going to similar companies for power systems. So Airbus CRISA is a company that's actually out of Spain that both Halo and the IHAB have gone to for their power systems. Now, Airbus CRISA is not very pleased with NASA right now because when we did this, we allowed Halo and Northrop to go through with one set of requirements and ESA and TASI to go forward with their separate set of requirements. So CRISA doesn't have exactly the same requirements. They certainly don't have the same standards that they're expected to build to. However, they know that these systems have to connect over time, which is a big challenge for them. So what this does requires that they have to acknowledge both of their, say, masters, for example, both of their people that are providing them direct money, but they also need to make sure that the integrated spacecraft system is still going to work. The same is true with our avionics system. TT Tech out of Austria is actually building the avionics components for both Halo and IHAB. Now, the contractors, TT Tech and CRISA, are not pleased with NASA because instead of writing one very particular set of requirements that would make sure that it works all the way through, they had to work with each of the separate industry standards, separate requirements, and that's forced them to have to go out of their way. And what they would have preferred is that NASA just tell them exactly what they want to do, and it would have all come together beautifully. However, in doing it this way, the overall space community continues to build. So TT Tech, for example, is they're building up avionics components, which they've done in automobiles and aircraft and all sorts of other areas. And they're building up this big human spaceflight foundation. Is their components are now going to be able to be rated and then manufactured and offered as internationally approved systems. So since they had to go through all of the standards that the US has, as well as all the standards that Europe has, now they will be able to market those components around the entire world as being not just for a US vehicle or not just for an ESA vehicle, but available for all. So it's been a little painful for them as they've been coming through. However, this really helps enable that space economy, and having parts that are rated for more than just one specification is something that we've run against in the past. So that's another big challenge that we've been trying to overcome with our suppliers. All right, so here's sort of the latest status on Gateway. Just in January, actually, is when we brought on our latest partner, which we were really excited about. MBRSC is going to be a great partner. They're very excited, and they've got a great basis, a great foundation for building on their expertise with. Our latest module of the logistics module received its authorization to proceed, its ATP, back in December. So we officially have the authority to go forward with our overall ATP for Gateway, of course, was many, many years ago. We are continuing hardware fabrication. You saw some of the videos with all of our partners. You saw them from Northrop Grumman and Maxar. However, our Canadian Space Agency with MDA as their prime contractor, and ESA with Thales, both from Italy and France, JAXA and their primes have all been building hardware, and we're actually getting into testing in many areas. We completed our Gateway design review back last year. We are actually right now in the midst of our critical design review. We've got it right now going on at the subsystem levels, and that will culminate into an overall vehicle CDR informed milestone here, hopefully in late summer or the fall. And we use integrated analysis cycles throughout the year to continue to mature and make sure that all of our systems to be able to withstand the new build-ons that we have. For example, we know SpaceX is going to be building a lander, and now Blue Origin is going to be another lander. And so making sure that our systems are able to handle both of those different types of landers and provide the services that they need. So we're making great strides there. We've got great relationships with partners, but also our Orion partners. And in the future, we'll be working very, very closely with EHP, which is the EVA and Surface Habitation Mobility. I'm sure it's better than that, but they provide the EVA suits for our airlock that's going to be coming up in a few years. And so we'll be getting much more integrated with them here in the near term. So that is what I had to present about Gateway and some of the challenges, as well as some of the priorities that we've been going through. I am really excited to be here, and I could talk about this kind of stuff all day long. So I'm happy to now take questions, and let me get out of this so that I can see if I can stop sharing.
That was fantastic, Deb. I mean, it's so exciting, the stuff we have coming up, and I didn't realize the depth of the international cooperation. That is great to hear about.
Yeah, it's exciting. Thank you.
It really is.
It's fascinating to hear, and as Dave said, about all the parts, all the systems of Gateway and the partnership that works right now on developing, on building it, and will be working for many years to operate. So we have both lots to learn how to integrate with different systems, and also learning from what the impact from all the future research that will be on both on the lunar surface and with the focus on the future exploration of Mars. We do have a few questions that I see posted, and one was, there's a couple from John DeLoria that first he asked about, oh, hold on, let's see. He asked, somebody else actually, Daniel, asked about the current rate. In what time window do you think we will have Gateway built out?
Absolutely, good question. So our first modules, the power propulsion element and the halo, are right now planning to be launched in late 2026. So just a couple years away. But we also just caution that we know based on budgets that we get from Congress and based on continuing resolutions that many of you are aware of and how we kind of work that, we're going to continue to work across Artemis and the Moon to Mars program with what the final launch dates end up being. But right now our first two are scheduled for late 2026, so not very far away. And then we'll build on with the Orion cadence. As I mentioned, the following modules after that come up with Orion. So we'll have to work with them. And it's about every 1 to 2 years that we'll have our modules. So hopefully by about 2030, we'll be complete with our assembly.
And there's a question that was sent to me directly for you that one of our members asked that I'm curious to know if there is a backup for PPE in the event things fall through with Maxar. Also, what drove the decision to make PPE ion propulsion? Is it easier to store propellant gas over long periods of time? If you can.
So first of all, Maxar's not yeah. So Maxar's not going to fail. We are working very closely with them to make sure that they do not fail. So they actually next week have their critical design review, and we are participating very closely with that. We will make sure that they are successful along with all of our partnerships being successful. So we will work together. So there's not a backup option so much as you can always, go back and try to do another build to print based on the systems that they're developing. But that's not normally kind of the way we do things. We don't have a backup module sitting available for any of these modules. They're all one of a kind and pristine and made specially for us. So for solar electric propulsion, yes, the xenon propellant is much more stable over time. Many of you have heard of the challenges of like cryofluid storage and how that eventually burns off when you're in space. We couldn't allow that. Xenon is an incredibly stable propellant, and solar electric propulsion is a very efficient use of that propellant over time. So that's why we came back to that as being our primary for PPE. At the same time, we do have some hypergalls on board, and those will be used for when we need a quick burst of immediate power, mostly when we're very heavy, like when we have Orion or a human landing system that are attached to us. And that, it more than quadruples the mass of the Gateway. And so during those times, we do have a biprop that's available for us to jump in with that we will use very sparingly because it is a limited quantity. Now, our ESA refueling module, when it comes up, will bring us both xenon as well as additional biprops. So that will, between the tanks on power propulsion element and our refueling module, that will last us the 15 years. And then on the back end of the refueling module, we actually have the capability to accept more fuel, both xenon and the biprops. And so if we need to over time, we'll be able to allow refueling over time. We do not have a refueling vehicle that is in design yet, though. We don't anticipate that we would need that for at least another 15, 20 years. So we'll kind of get on that rock when we get there, but it's certainly a challenge that we're willing and open and waiting for in the future. Oh, Svetlana, you're muted again.
Yep, that was the dry run. Right now, the real thing. John DeLoria had posted the question about JAXA, that JAXA is developing a lunar work bus. What time period or for Artemis phase? This is not related to Gateway.
Yeah,
I'm sure.
So JAXA is developing a lunar rover. Is that what's meant by a lunar work bus? A pressurized rover, and that is part of a different program that's working on surface operations now, the EHP program. So I don't know the exact time period. I think it is around the 2030 timeframe as well, though. That's probably something that we should go look up online. They might have something posted.
Okay, how much money does the construction of Gateway cost?
So that's a really interesting question, and we never quite calculate overall cost of this, in part because so many of our pieces are being developed and provided by partners. So the partners, NASA doesn't pay for those. NASA is not paying ESA to develop an IHAB, for example. ESA is going off and through the European Space Agency and the agreements that they have across their partnerships, they are bringing their own pieces to the table. I will say Gateway has, I think it's about $700 million a year budget right now. And that's available through congressional budget, the bills that you see. So that is open source information if anybody is interested in looking. But that is, I'd say, a drop in the bucket compared to what some of the other vehicles for lunar exploration are going to be. The Human Landing System, for example, is about 3 times that. And we know Orion and SLS have been in work since, 2006 or so, and have been, between them billions a year for 15 plus years. So overall, the Gateway budget is a relatively small sliver of the overall Artemis program budget. However, it will be very useful and will allow us, 24/7 connectivity with the moon, 24/7 space exploration and science instrumentation for years to come.
Thank you. And Rock asked if will PP Halo stack be integrated to the Falcon Heavy horizontally, or is vertical integration required? Kind of very technical for just for you question.
Yeah, so actually, I am not sure how the integrated stack will get launched into space, or will get stacked into SpaceX. I know the Halo and PPE are going to be horizontal integration on the ground. So they all have fixtures that they meet on the ground. And some of the interesting challenges, initially we had planned for a power propulsion element to fly up independently, and then for the Halo to have a bus, basically a small engine system that's attached to it to fly it out to power propulsion element. But when we changed that, we actually changed the configuration of the launch vehicles such that the power propulsion system now is upside down compared to their normal launch orientation, and they have to handle the loads of Halo on top of it. So it's been a huge change structurally for them and how they're used to launching some of these vehicles. And we've worked very closely with them and with SpaceX to make sure that we can get that built all the way through. Our SpaceX launch vehicle is being provided to us by the launch service provider out at KSC. So basically, they are the one-stop shop for when you want to launch something at KSC, come to us and do integration with them. And so they are our main conduit back to SpaceX and how we're building up that commercial architecture with them as well. So I'm not sure how it will actually get integrated into the SpaceX vehicle, but horizontal between our 2 main vehicles.
Thank you. What is estimated time from the launch of Gateway to Artemis 4? No, Artemis 7. I hope
Artemis
it's
7.
Artemis
Well,
4, but I'm not sure.
No, that's okay. So our first launch vehicle, well, right now it's planned about late 2026 for those 2 modules. They will take about 12 to 14 months to actually get to the lunar vicinity. So it is a very, very slow spiral out. It takes a very, very long time with the xenon propulsion. That's once again low ISP, low propulsion, low thrust. However, it's very stable over time. So our Halo and power propulsion element will take about 14 months to get there. And so Artemis 4 right now, I believe, is planned for early 2028. So that'll be when we bring the IHAB up. And then we have about a year to 2 year cadence after that. So our intent is, from the time that we launch our first piece in 2026 until we're fully outfitted, about 5-ish years.
Great. Tom asked if there were any lessons learned from ISS that were applied and influenced the design of Gateway.
That is a great question. And I will say all the lessons learned from ISS have been used to design and influence Gateway. So I actually meet at least or about once a month with the leaders from the ISS vehicle office and the ISS avionics and software office and power and software office. So I even now am using their lessons learned on things like where they've had failures with equipment and what can we do differently. Where they've had supplier trouble and like that's not the supplier you want to go to. This is the one you want. However, this is how you work with them because they're persnickety in this way, or even down to those kind of procurement questions. But overall, huge lessons learned are, first of all, international partnerships are key, and how we work with our international partnership is as well. So we learned from ISS the things that were going really well with how they worked with their partners and what they've learned over the last 20 years. We work with our partners. So I talked a lot about that already. But not only for the relationship with our partners, but when we have an international partnership like this, it becomes a key to longevity. Anyone who's worked in the government or around the government for any period of time knows the political swings and how the wind blows differently depending on who's in office and really what the political flavor of the day is. And so having these international partnerships allows us to have a foundation in longevity and an international treaty actually in guaranteeing that we're going to work together on this over time. So it provides the stability programmatics that many programs don't have, which is why you see some of the swings and things are what everybody wants now, but then 2 years later they get canceled. So that was a huge piece. Things like integrated testing, we have learned tremendous from ISS and how they use their Sonny Carter test facility and how we're going to use our test facilities and the kinds of integrated testing that we need to do over time. We have learned from ISS on things like radiation performance and what happens in LEO as compared to what we think is going to happen in NRHO in the. So when we're doing things like we're buying laptops, like ISS uses hundreds of laptops, we're buying laptops for a main command and control interface for our crew. So we did joint testing with ISS on what kind of radiation testing can we do on these systems. So down to individual components even, we are continuing to collaborate and build with our International Space Station brothers. A lot of times we refer to them as our big brother because we are following right behind them and trying to do everything that they're doing. And then we try to do it. Okay, well, let's learn from that and do it a little bit bigger or a little bit better or a little bit different. And so I would say that we're doing that day to day in addition to foundationally how we got started with Dan Hartman coming from the International Space. Even our organization is very reflective of the ISS organization down to how we were first developed. So it's a great question.
True. Thank you, Deb, and thank you, Tom, for asking. Question about back to Esprit and the PPE and Gateway. Can Esprit only refuel PPE, or does it have capability to refuel other other spacecrafts docked to Gateway?
Right now, our refueling vehicle will not have the capability to refuel anything else. And the reason is because when we do, the way you would transfer that fuel is basically through each of those docking systems. So all the fuel would have to be piped through to get to where it needs to go. And the only docking system that has the right connections to get fuel from the refueling module into where we need it is through the halo into PPE. So we don't have external systems then that will allow additional refueling beyond that. We actually talked about that. So I've been in the program since we first started formulation back in 2017. And we talked about that as a potential service to be able to offer. And we decided not to for lots of reasons. But the biggest one was because each of the manufacturers, the spacecraft manufacturers right now, are going their own ways with the type of fuel that they're using. So for us, we certainly couldn't have done all the different types of fuels that they could use. Our vehicle is incredibly small. I didn't put in here sort of a comparison in size to International Space Station, but we're about a quarter the size of this International Space Station. When we talk to the crew, like crew that have gone to the ISS, we talk about, you're going up to the Hilton there. And when you come to Gateway, you're going to be camping. So the amount of space is significantly smaller. We just don't have the room and we just don't have the amount of module space to be able to do all of these. And since each of the providers was going such a separate way with the type of fuel that they were using, we weren't going to be able to accommodate everyone. And so it didn't make sense for us to try to pick and choose which ones we would accommodate. Also, fluid transfer in space is incredible. So ISS has been able to do it with the Progress vehicles to some extent. However, it's a relatively minimal distance and it's a very contained and controlled infrastructure around it. Our refueling system is going to be an order of magnitude more difficult than that. And then additional types of propellants, then you even more. And one of the things that we do is, of course, keep our risk in check as much as possible as always space flight and trying to figure out what are the risks that we absolutely need to overcome and what are the risks that we can avoid. So we did not go that path for Gateway.
certainly expanding the number of vehicles and types definitely grows the risk posture is just to the point that it may become unmanageable.
Yeah.
We have also a teacher that she's at teaching at Odyssey Academy Galveston, and she's excited about the upcoming things that are coming with space exploration. So she thanks you for a presentation, excellent, and can't wait to, in addition to that, she already had built a replica of ISS with her students. She's also looking forward to building a replica of Gateway. We would like to see that, at least a picture. Once you build a replica of Gateway, please do share with us. And I assume that she's the educator associate member of AAA, and so appreciate of her joining today and sharing that information with us. And Rock,
yeah, and Svetlana, I hugely appreciate that, and thank you so much for being here and for being a teacher. I'll just mention, so yesterday I took my kids out to Space Center Houston, and one of the cool, there's so many cool things at Space Center Houston, but one of the things that we always spend a little bit of time on is looking at the previous accidents that we've had. So we're looking at the picture of the people from Challenger and Krista McAuliffe and the first educator astronaut, and actually talking to my kids about that and how important it was for NASA to reach out and really to partner so closely with education and STEM development. And so that was huge. And I'll say, I noticed something yesterday, which I had never noticed before. So I've been studying Challenger and Columbia and Apollo 1 for so many years that I've been at NASA. And I had never on their mission patch, there was a little apple next to McAuliffe, next to her name. And I had never noticed that before. And, you know, of course, the emotions just flooded in, and I'm like tearing up as I'm seeing this at Space Center Houston. But it once again reminded me of how important it is to bring and to have them following along with us, because this that we have here are just amazing. And the more that I get to work with different people at NASA, even the more I am constantly amazed by how wonderful the teachers are that brought them up. So thank you.
Yes, indeed. And thanks for being a teacher and sharing knowledge and growing our future engineers. We do need them. Absolutely. A question from Rock again. Could the Gateway be already visited by the Artemis 3 crew if HLS schedule moves beyond 2027?
Yeah, Rock, that's a really interesting question that we're struggling with across NASA right now. So we've got this new Moon to Mars program office, and Amit is the lead for that, and he is probably one of the top 3 smartest people I've ever met in my life. So one of the things that he's been doing over the last year is a series of leadership sessions where they've been talking about what kind of options are there, what kind of downloads are there, what kind of risk reduction opportunities are there. He's done a lot of studying, and we've all done a lot of studying on how did Apollo do risk reduction over time, right? From their flights all the way up until they did a moon landing on 11. So there was a very, very conscious series of events that they wanted to demonstrate very specific tasks over time. And so Amit is leading the leadership team, and what are those specific tasks that we're trying to do? What are those functions that we need to prove? And if we have, waivers in this area or challenges in that area, what kind of flexibility might we have for mission flexibility? So all of that is in that discussion. I think it's really important that we are open and trying to continue to build and learn based on what we're doing. For Gateway in particular, we have developed Gateway such that in any configuration, then visiting vehicles can come and use our. So it will be highly dependent, of course, on the actual orbital dynamics, the masses, and the different types of corridors that we're talking about when we do docking. However, we absolutely have in scope and built into our plans the ability for crew to dock to a PPE Halo only module, given the right circumstances. It would have to be an axial dock, so basically on the end, where the IHAB port is right now. That would be the most stable, especially if you're coming in as a very large vehicle, and even Orion is large compared to Gateway. So we have already built in to those designs such that we can accept visiting vehicles at any one of our ports. They're all that standard international docking standard developed port, so we can use any of them. We would just manage that port selection based on the configuration that we're at. Orion, for example, is being designed to be able to go to any one of those ports based on what is there as well. So we're being very flexible in our mission availability from that perspective.
Great. And so next question is, how many missions? Mike asked if how many missions to the moon can Gateway support at the same time? For example, how many ports does the Gateway have to handle the various spacecraft to go back and forth from the Earth to the moon? And I think you partially answered some of that portion of this question earlier.
Yeah, and I was actually just thinking I need to pull up my picture and actually count the ports. Because it's changed a little bit over time, but generally, let's see, we'll have 3 on the IHAB and airlock when we're fully fitted out. We'll have 3 on the IHAB airlock area and 2 on Halo that are available. So a total of 5 ports available. One will probably, if we've got a crew mission going on, one will probably be taken with a logistics module, because we will need the stuff, right? We will need the suits, we will need the food, we will need the air, we will need all the stuff that it takes. And then we will have 1 for whatever crewed vehicle, whatever brings the crew from Earth, and 1 for whatever vehicle goes down to the landing site. So that basically takes up 3 of your ports. So you still technically have 2 that are available for backups or that are available for other things going on. So right now, the only crew vehicle that we have that is designed to be able to go out to lunar vicinity is Orion. However, we once again utilized our international standards to build 2 things that if SpaceX decides to build a crew vehicle that can go out into deeper space, that it would be able to attach to Gateway as well, would actually physically be able to dock. Same with any other provider. You know, Joe's spacecraft shop that pops up around the corner that I don't even know yet. They will be able to dock to Gateway, you know, of course, given all of the right agreements and all of the right configurations and all those discussions. But given our international standard that we have built to, they will be able to come up and dock. And so that's partly why we're also able to, we talk about being a crew for up to 90 days. Well, really, that's only based on logistics. We can support crew for as long as there's enough food and water and air and whatever toiletries that they need to be able to stay happy and healthy. Based on our system performance. We do not have any systems that are on Gateway that are limited in scope to a certain amount of time. They could be used continuously, and many of them will be used continuously. Even when crew's not there, we still have to do thermal cycling, right? So there's no limit on that. However, right now, the only system that we have that can bring crew up is Orion, and they're only set for 4 crew at a time. So that was a very long way to answer, but I think we've got lots of flexibility built in. That was one of our sort of grounding rules when we were first developing gateways. We want a robust architecture that is able to handle lots of different scenarios, because we don't know what's coming next. That's a lesson learned from ISS, right? We don't know what it's going to look like in 20 years. We need to be able to upgrade. We need to be able to be flexible based on the missions that we're provided with.
It is a great answer. And the next question is, how are Gateway systems adopted for the high radiation environment around the moon compared to ISS systems? How many backups do Gateway system have?
Well, that's part of the fun. So we know less about the environment around the moon than we do about the environment around Mars in a lot of ways. So we don't really know what our actual radiation environment is going to do to our vehicle and to our systems. So what we've done is we have built in, once again, trying to be reliable and robust. We have built in robust systems that could be used in lots of different ways. We have radiation tolerant systems, and we can test to that to some extent on the ground. We have radiation tolerant systems for absolute critical things. So like we've got a human interface panel that is a very, very Apollo looking, old school. Svetlana probably knows it better than me. Very old school looking box with a digital display that looks kind of like a calculator up at the top for me. and it's got your absolute critical functions that you absolutely have to do, like a hard stop for a robotic arm so that the robotic arm doesn't punch through a structure, so that you've got a evacuate now kind of button that you can press. I mean, absolute minimum, most critical items. But most of our onboard systems are very similar to how we've done the International Space Station. We're going to continue to live and work. And what we've done is we have included in our design plans the ability to do an R&R, to do a repair or replace on a lot of these things as they come up. We knew, for example, that we were never going to be able to do Star Trek like a whole wall of screens and buttons that would remain forever and be able to withstand all of the different environments, because we don't know what those are going to be. So we didn't want to embed that into the vehicle and limit us to that and then having to constantly repair that. So the crew interface that we have is a laptop. It is a commercial based laptop. And what we're doing is we know that these are probably going to sputter based on radiation effects. And so we're manifesting twice as many as we think we're going to need. So we've got basically one laptop per crew member that we're planning. So we've got 4 laptops available actually on the vehicle, and we're going to have 4 cold spares that are packaged up. We know that radiation tends not to affect things that aren't actually on as much as they do the things that are on, based on the testing that we've done. And so we will have them as spares and backups, and you can go pull out the bag and pull out another laptop if that happens. The radiation effects are sporadic, and so it's not, in some areas of radiation, it's a constant bombardment from the sun. However, we will get solar flares and we'll get different types of things that will be sporadic, and we think those are the events that will cause us the most damage in terms of our laptop usage, for example. And so we're just manifesting extra, and we're going to figure out how it works together. Now, we're also looking at where is the safest place in the gateway for crew to be if we know that there's going to be a radiation event coming up, if we know there's a solar flare. And right now, that's going to be in Orion. So Orion is always going to be our safe haven. You want to make sure that the crew is in the vehicle if it turns out to be a bad day, right? So when we have notifications that something is going to actually affect from a big radiation environment, for example, the crew will go shelter in Orion, which Orion would have to have, basic radiation shelter in place anyway, because Orion has to be able to travel with crew with their vehicle there. So we're utilizing that experience instead of adding on like a water wall or a big lead-lined wall. We're not doing that in Gateway right now. We're utilizing Orion because it already has that capability built, and we can be efficient that way. So I hope that.
Great answer. Great answer. Thank you. Thank you. During your presentation, you have covered on the transition between the launch and to the lunar orbit, and perhaps you can slightly provide additional details, because Daniel asked if the gateway be assembled in a low Earth orbit or around the moon, and perhaps it wasn't very clear for him, the assembly.
Absolutely. No, I appreciate that. So it will be assembled around the moon. So the first 2 modules, the power propulsion element and Halo, will be jointly assembled on Earth, and they will be launched together, welded together. So they will launch up, and then the power propulsion element will do its slow spiral with Halo and bring it out to lunar orbit. And so once it's in lunar orbit, then that is where the rest of the modules will come together. So Orion will, so kind of how it works, and forgive my hand signals, I'm very crude here, but so SLS will launch, and the co-manifested payload will be in the top of SLS. In a lot of ways, very similar to how Apollo did. It will be on the top. Orion will turn around and come back and dock with it, while that module, while the IHAB, for example, is still attached to the upper stage of the SLS. So then the SLS will release the IHAB, and Orion will take that, and then Orion will ferry it out to the lunar orbit. In lunar orbit, Orion will attach that IHAB, and then the Esprit refueling module, and then the airlock will attach all of those individual pieces to the gateway while in lunar orbit. That's kind of the orchestration. And each of those times, Orion will basically have 2 docking, right? They'll have their initial docking in low Earth orbit while it's the stage of the SLS, and then its second docking when it gets to gateway.
And some of the assembly and also maintenance will be performed by the Canada arm, but by the Canadian contribution.
Yes, that's a really good point that I should have mentioned earlier too. So part of the joy and the fun of our new international docking adapter, our docking standard, is that dockings are done without crew involvement. So on ISS, as we know, as the pieces came up, we always had to do a lot of EVAs, and we had to do all sorts of connections and make sure things were fitted just right before we could like open the doors to that module. Well, on Gateway, as soon as you finish that docking, then you should be able to open that module and be able to utilize that extra module or that new module that's there. We do not have any EVA that's required in order to actually do the docking and the buildup of these systems over time. So that's thanks to our international docking standard. Also, the NASA docking system that Boeing is actually building is built with that in mind, is built to be done autonomously without crew engagement, without crew involvement. And so ESA's version of that, it's the IBDM. I'm not sure what it's International Berthing and Docking Mechanism, I think is what it's called, is also designed such that you do not need any crew involvement in order to be able to do that docking, which is a huge change. So we have the robotic arm up there. The robotic arm is to be used for external maintenance and science instrumentation, to be able to move around science payloads and to be able to do that. But it's not for primary construction, for example.
That's great. I wanted to point to all of the participants that Aimeta had posted the YouTube video, link to YouTube video, what they built, and that it will be also, if anyone attends the Moon to Mars Festival at Space Center Houston, you will be able to see it there in person. And one more question, and you basically answered her question about the maintenance tasks outside, whether it's EVA or automatic. And in most cases, will be done by or planned to be done by the robotic arm that is Canadian Space Agency contributes. Rock asked, and this is with the emergence of AI, everyone is interested. How is Gateway planning, and is Gateway planning to integrate AI into the operations of Gateway?
So that's so interesting. So artificial intelligence, I can't say that we use those words. However, what we do use is autonomy. We talk a lot about autonomy. And autonomy is basically the ability for the spacecraft to be able to work without human intervention for periods of time. So we have a couple of different ways that we treat autonomy. One is independent from the crew that's actually on board, and one is independent from the ground here on Earth. So we have developed a new type of software. It's called a Vehicle System Manager. And this is a software system that is allowing us to build in a lot of pre-planned activities that, for example, on the ISS are all having to be done by ground control here on Earth. So we're using a basis of core flight software, which is available for anyone, theoretically. We have adapted a core flight software module that's very specific to Gateway, and using our core flight software and integrating new software from this Vehicle System Manager, we have done all these pre-programmed scenarios where crew, both ground and flight crew, have had to be engaged in the past and will not have to in the future. So we, for example, have a requirement on Gateway that it needs to be able to handle 21 days of autonomy. It needs to have 21 days without crew interaction. And so we wouldn't expect it to be, operating with, roses and butterflies during that time, but we would expect it to be able to stay safe and stay in a configuration that we can come back and reintegrate to after 21 days. So we've done that in a few different ways. So we've got this onboard software that is able to handle those kinds of emergencies. If there is a pressure loss, if there is a thermal heat and getting heated more than we would expect it to, that the vehicle has in place the pre-planned software commands and controls to be able to adapt to that and to work its way around and reconfigure for those kinds of situations. For power distribution, on board will be able to manage its power distribution systems, manage its battery loading, and keeping it in range for longevity, right? We want to keep our batteries as efficient as possible. And so we've already got all of that kind of in place from a vehicle system manager perspective. We've also built into our architecture some things like the orbit is incredibly stable. So you can, we will plan to do an orbit maintenance maneuver about once a round, which is about every 6.5 days. However, we can last probably 6 or 8 revs without doing that and still be able to recover. It'll cost a little bit more in fuel when we do get it back up and running. However, the stability of that orbit has allowed us to be able to hang out and be safe for a while, even if we lose ground involvement, if we lose the ability to do something for some time. So that gives us big chunks of time that we're able to troubleshoot and figure out what's going on and still be able to recover. So I can't say that we're introducing AI, for example, but we are doing lots of things to introduce autonomy into this spacecraft because we know these are going to be absolutely imperative when we bring people to Mars in the future, because they're not going to be able to spend doing all of these different spacecraft management tasks. They're going to need a system that is smart enough to be able to manage those things on its own.
But it has to be predictable and explainable. And with the AI, we don't have yet that explainability to the point that we can just let AI run the station without human interaction. So just to add to what Deb had mentioned, yes, we are developing VSM, Vehicle System Manager, but there are some incorporation of machine learning algorithms into that system, but not to the point that it can be called AI, depending on what you put into the definition of AI.
And for those of you that don't know, Svetlana is one of our leaders in our avionics and software sort of integration and development for Gateway. And so I should absolutely be deferring to her on a whole bunch of these questions because she's much smarter at it than I am.
You're doing great. You're doing great.
She'll correct me, I hope.
I'm very happy, and I want to point that you have been talking nonstop for over an hour. So we probably will ask one more question and we'll just cap at that, because I really appreciate, and I do not want to over exert that your speaking capabilities at the moment. And perhaps we can reserve the right to invite you again, and you can provide the update in future on the Gateway development and interaction. Obviously, you can see that AAA Houston section is very interested and eager to learn more and know what's being developed right now, what's being planned in future, and so on. One more question that can Rock again, and Rock is not asking just for himself. He's just want to mention that he has some of his friends that are not as that are a little bit more shy and do not ask all the questions. So he's being a front face for some of his other friends that are behind him. That can Gateway modules be undocked and redocked to a different docking port if the station has to be reconfigured? Can you
so yes and no. Oh, I'm sorry, Svetlana, what did you say?
Can you talk a little bit about that? Right. Yes and no.
Yes. Yes and no. So based on the actual configuration of our docking ports, there are some things that can only be put in certain places. For example, between Halo and IHAB, there's only one place that we can do that, specifically because we have main lines of power distribution systems, so high power distribution that goes down that trunk, for example, axially. So IHAB has to be part of that main power distribution. So anything that goes off onto the appendages of that can theoretically be docked in a different location. So well, that's not quite true. So the airlock right now does not have any specific services, specific docking mechanisms. So it could be put in a different place. So, and it is actually being designed so that it can be berthable. So initially it will come in and be docked by Orion. It can be berthed, like unberthed by the Canadian arm and rebirthed into a location. Now that would be something that we would put a lot of thought into and really figure out if we want to do that. The Esprit refueling module is the other piece, the other permanent piece that comes off of a side, basically. And that can only stay in that location because that's where the fuel distribution ports are. So those are we only built in the biprop and xenon refueling lines into that one port. So it needs to stay where it is. The logistics module is something that comes and goes based on mission. It will come up and bring all of our things, and it will leave and take away all of our trash, or all of our excess, basically, because there's very little storage space on board. So the logistics module will be able to dock to any of those ports that are available. And there will be one available on the back side of the airlock as well. So it will be able to dock to any of those ports that are available. And then Orion and the Human Landing System will also be able to be docked to those other ports based on the configuration and reconfiguring the gateway. All of those different vehicles have their own constraints that they have to us. So it's been a real challenge to figure out how can we make everybody happy. For example, Orion always wants its tail to the sun because that's where its arrays are. And so it wants to make sure that its arrays are getting all the power. The Human Landing System always wants its nose to the sun. The SpaceX Human Landing System always wants its nose to the sun to decrease the amount of heating so that it loses the least amount of fluids through burn off as possible. And when you do that, you put Gateway in a very sun-sensitive attitude and also a very difficult to dock in attitude by large vehicles. And so we've had to take all of these different constraints and kind of come up with what is the best situation and what is the best docking configuration that we can do. And sometimes that means Orion initially docks to one location and, you know, inserts the iHab, for example, and will move around and dock for its actual crew mission at a different docking port. So we have the ability to be reconfigurable from that perspective. But the only permanent module that is really able to be moved right now will be the airlock.
Fascinating. Lots of engineering challenges, and right now and for in future to come. So thank you so much, Deb, for coming and sharing both the love, the energy, and enthusiasm for Gateway, for space exploration. Appreciate it greatly. And as we celebrate and recognize the Women's History Month, March, we also recognize all the women that contribute to the space exploration and creating history pretty much every day. So thank you for sharing your love to engineering, to space, and sharing it with us. I wanted to mention before
Thank you so much. My pleasure.
Yeah, thank you. Before we stop the end today meeting, a couple upcoming AAA Houston events. That next Saturday we will have talk about the lunar rover with from the Apollo era, and then on the last Saturday of the month we will have Julie Strickland. She will actually do 2 presentations the same week. She will be presenting at the ION Houston on March 28th at 6 p.m. If you would like to go there in person and both support and interact with her. And then she will come to our platform, to SpaceGeekSpeak on Saturday, and will represent the same or similar presentation again. And you will have another option to ask her questions and interact with that fascinating speaker. And then we have also networking social on March 21st. Will be at 5:30 this time at Nobby, and technical seminar on drone detection will be on March 22nd at 10 a.m. You are welcome to. All this information is posted on AAA Houston section website, and you can get all the details there. With this, thank you very much. Thank you to our speaker today, and thank you everyone for coming and attending and engaged with all the questions. This makes it more interesting and learning experience for all of us. We'll see you next Saturday. And until then, keep on exploring and share the excitement with everyone that you know. Thanks.